This is Note Taking Guide 9.0 for Math 3, and this is going to be talking about the period of a cyclic function. So first of all, let's kind of talk about what the word cyclic means. Cyclic actually means a cycle, and so a function that is cyclic means that it would repeat in the same pattern. So it says right here in this paragraph that periodic functions are functions that behave in a cyclic or repetitive pattern over a specific interval called a period. The graph repeats itself over and over as it's traced from left to right. In other words, the entire graph can be formed from copies of particular portion repeated at regular intervals indefinitely. So really what that means is that you can take a portion of the graph, you can look at it, and if you cut that portion of the graph out, you could place it back on other parts of the graph because it's that same portion of the graph that repeats itself over and over and over again. And it only repeats itself for a definite interval. That interval that it repeats itself for is called the period. So what we're going to do is we're going to look at this graph right here of this function, and we're going to decide what the cycle is of this graph. So it says here to figure out one cycle, and you can see that this graph goes down and then up, down and then up, and then down. And the arrow means it's going to keep following that pattern. So it still would go up again, down again, up again. So in that same pattern, it would be repeating itself. So what we're going to do to decide what its period is, or for the amount of time that it takes before it starts repeating itself, is I like to start at 0 and find how long it takes for this graph to repeat itself. So if you notice here, when we start at 0, it starts up here at 1. Then it goes down, and then back up, and that would be the spot where it looks like it's going to start repeating because it's down and then up, down and then up, down and then up. So what we're going to do here is we're going to see how far, or the interval that it took us from here to here for that pattern to start repeating itself. Well, if we started at 0 and we ended at 360 degrees before it starts repeating it, our period would be 360 degrees. It's the amount of time, or the interval that it takes on that x-axis before it starts repeating the same pattern over and over again. So on this next problem right here, if you read the instructions to the left-hand side, it says, here is a period function. The graph of the function begins to repeat itself after the interval of 2 pi. So the period of the function is 2 pi. So when we look at that, again, I like to start at 0. And if you see here at 0, it starts down here at 0, 0. So my pattern, or my graph, goes up and then comes back down and keeps going down, and then it comes back up. Now if you notice from right here, this is where it starts repeating itself. Even though you can't see it, this would be another repeat of pattern from here to the next one. It would be down and up again, and another repeat pattern from over here. It would go back down and back up, and the pattern repeats itself. So if we look at the actual area that it repeats, is it starts at 0 and it ends at 2 pi before it starts repeating again. So again, the period of this would be 2 pi. This next example here says determine the period of the function. The answer is down at the bottom, but let's kind of just look at it before we look down there and see. If we decide where we start here at 0, we're starting up here at 1, we go down, over, up, and then if you notice, if I took just this piece of that pattern out, I could pick it up and I could place it right over on top of this one. Again, it would form the exact same pattern. So I know that that's the end of my repeating pattern. It starts at 0 and it goes to pi. So the period of my cyclic function here is pi. One more example. Here we are with the period of this function shown below. Again, if we start here at 0 to see where we start, we go up. We start up at 1, we go down, and then we go back up. And then again, if we took that, just that piece of that out right there, it would set directly on top of the next piece here and directly on top of the next piece there. So we know that that's where our pattern repeats at. So because of that, our period of this function, or the amount of time that it takes before it starts repeating, is a period of 10. So just to recap, what we're talking about here is we're talking about the period of a cyclic function. Cyclic means that it repeats in a cycle, and the period is the length that it takes, or the interval that it takes, before it starts another repeat of the same pattern in the graph.